today we are going to to continue with the process strategies. In last class, we stopped at the crossover examples. We only finished the first two examples. And this crossover chart helps us to understand which strategy will give you a better option in terms of economic benefit. So that's the first example. Compare the software A, B, and C. We use the crossover point and find out. So in class practice, we can compare individually the pair A and B, and also compare A and C, B and C. So when you solve the three equations, you can find out three individual crossover point. And this crossover point, for example, we have 2857, which is this point. And another crossover point is 4000 over here, which is A and C. When you look at the lines, it is A and C. So for comparison B and C, you can draw the line to show, okay, this is 6, 6, 6, 6. So, and then it can give us the range. When your quantity level it is less than 2857, you are going to pick A. A is the smallest total cost. When the range is, the quantity is larger than the highest crossover point, and then you are going to select the number C, which is the smallest fixed cost, but it is the highest fixed cost, but it's the smallest unit cost, variable cost. So, and in between, so we can pick, so B, it is the lowest level. So actually, and example A and example B, they are the same kind of like formula. You all use the formula is a fixed cost plus the quantity level times the unit cost. So here we already have the kind of like given the quantity level equals to 200,000, but we have the variable cost over here, also given the variable cost. So different variable cost we can, because you can still use the first strategy to solve the problem, but here because we have the quantity level already, we can use the formula to find out which one it is the smallest total cost. So today we are going to solve problem 3 and 4. For 3, that's this company is a stance company, is considering producing a gear assembly that is now purchased from Salt Lake Supply. Salt Lake Supply is charged $4 per unit with the minimum order of 3,000 units. So, and also it says Salt Lake Stan estimates it will cost 15,000 to set up the process, and then $1.82 per unit for labor and material. Try to determine the number of units. Either choice has the same cost. So, and in this case, he has two choices. One is produce on its own, right? Produce on its own. And produce on its own is going to have the total cost include two portions. So insert the total cost equation. Total cost equation equals to variable cost plus quantity level and times the variable cost. Variable cost. So, and here, so in this case, we can write the total cost equals to variable, it is fixed cost, and in this case, the fixed cost, it is 15,000. This is include set up the process or change the machine and prepare the machines to get ready. So here it is 15,000 plus variable cost equals to and $1.82. So this is the first option. It is produce in-house. And another option is purchasing from Salt Lake and supply. So, but and Salt Lake Supplies is set the minimum order it is 3,000. So, but they give you the charge as that's the cost should be just the unit cost times the quantity. Times quantity level. And then we can write this equation equals to it's $4. And they said determine the number of units and where either choice has the same cost. It has the same cost, which means the total cost equals to this total cost. Then we can write the two equations together is this one and equals to Q. So you can simply solve this equation is insert equation. It is 4Q is 1500 equals to and 4Q and subtract 1.82Q. Then Q equals to 15000 divided by and 4 subtract 1.82. And do not miss the parentheses. Okay, and in your calculator, if you miss the parentheses, your result will be totally wrong. So 1500 divided by 4 subtract 1.82, and this one equals to about 6881 units. So this is the units, the two options will give you the exactly same result. And if you want to draw the lines of the two equations, so here the mathematical kind of like algebras and will help you to draw the lines. Okay, how about we draw the lines like this? So this is the Q. And here it is the total cost. And then, and for Q, this one, this is the Salt Lake Supply. So if I write over here, here should be Salt Lake. Lake supply. So I can make this no outlines. And another line we want to draw, it is their in-house and produced by themselves. They include fixed cost. If you are familiar with algebra 1 or algebra 2, the linear line y equals to a plus times bx. Bx it is, and then bx, b it is the slope. In this case, 1.82 it is the slope, correct? And how about 15,000? This one it is the intercept with the y-axis, correct? So this is the intercept 15,000. That means this is a positive number. Positive number, that means, okay, here it is my kind of like this line. And this line, the key point of drawing this line, it is you have the intersect 15,000, and also this line's slope will be smaller than the Salt Lake City, because Salt Lake City, what is the slope? It is 4, correct? When you have a high slope, that means your curve is going to be really, really close to the y-axis, correct? And then I will label the second line with this one. I said, okay, so probably not do this, and I will copy this one. And here, put this as produce in-house. In-house. All right. And now you see at this point, this intersection point is 6881. This is a point to tell you the two options will get the exactly same total cost. When you have and the quantity order and is larger than it is this one should be really over here. It's 6881. It is larger over here. Which one? It is a smaller option. Producing in-house is the smaller option, correct? And when your order it is less than 6881, and this portion and the Salt Lake City, it is a good kind of like option. However, they only, if your order it is less than 3,000, will they offer you this price? No. So this picture will give you some idea in which range you need to select which option, right? Yes, that's the main idea of I want to add the number over here for this one. This is the number 5. Number 5 is not kind of like very clear. When you read, when you want to really be careful. So this one is the team is considering outsourcing the daily room cleaning up of its motel to a service company. This service company is called Duffy's Maid Service. And the team rents an average of 50 rooms for each of 365 nights a year. Team's cost and to clean up a room, it is $12.5. And also says Duffy charges and 18.5 per room. plus a fixed cost 25,000 per year on items like uniform with the hotel's name, blah 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 blah. So that's the fixed cost. Team's fixed cost for space, for equipment and supplies is 61,000. What is the preferred process for team and why? And clearly, this is another kind of like idea to figure out what is the total cost. And the total cost include a fixed cost plus variable cost times the quantity level. So for the outsourcing, so let's say, because outsourcing seems kind of like a little bit easier. Okay, so here it is. Or over here. Well, okay, for two options, outsourcing and a fixed cost. So it's very clear, as I said, and it's $2,500. And outsourcing is a variable cost. It is 18.5 per room. And if he did on his own, teams and fixed cost. Also, is said clearly, team's cost and it is team's fixed cost for space, equipment, supplies is 61,000. And the team's variable cost and equals to 12.5 per room. Now, after you write this kind of like individual conditions, variable cost, the fixed cost, we can have the equations right over here. So total cost. So I'm going to write the equation, insert and the equation, and total cost. Add sub. Here it is outsourcing equals to 2,500 plus and 18.5 times and the cube. And then for teams, total cost. So this is a 61 and plus 12.5 cube. So, and we want to find out what is the crossover point. Equals to 6100 plus 12.5 and cube. equation is 12.5, 18.5, and Q subtract 12.5Q equals to, and subtract 25000, and then we can easily solve Q equals to and divided by 18.5 subtract 12.5. All right. So our result is here should be room units. The crossover point you find it out, right? So how about in Teams condition? In Teams condition, how many rooms? Need to be cleaned up. So Q equals to, look at over here. It said team rents an average of 50 rooms for each of 365 nights. So in a year, it is 365 times 50. So I want to use the equation because I think the equation is beautiful, like a document over here. If I write over here, so write an equation, and Q equals to 50 times 365. Per year. Q equals to 18,250 rooms per year, because all the costs, if you see over here, it is 25,000 per year, and here is 61,000 is per year. They are all yearly based total cost. And now, if you want to draw the lines, you will see all right, and for Teams service, its own service, that is the Teams line. And for .face service, it is outsourcing company charge 25. So team service, I want this to be higher, to be like this. Teams is high and low. And another one, so we want to insert and draw another line. 25,000 is a smaller intercept, but it is a higher kind of like a slope. So this line, it is Duffy. Now this point, it is 6,000. You can draw a line like this, 6,000. And however, in the Q larger than Q equals to the level of Q now is equals to 18250. It's clearly is larger than the crossover point. And then from this chart, we see Teams cost is smaller than Duffy outsourcing. So, and now you can say, and what is the preferred process for team and why? And you answered this question because, okay, total cost, Teams is smaller than the Duffy's service. Now you want to select it is do it in-house and without using the outsourcing service. Okay, save this in classwork and wait until I let you submit. Okay. Probably will be 9 or I'll wait or submit with 10 together. I will open this and let you submit course content over here. And so this is 7. So go back to week. In class practice 9-2 and finish up of in class practice 9. Submit your work by 10 p.m. October 8. All right. Did you finish this part with me together? Okay. All right. So then I'm ready, pretty much ready to move to the next portion of the class. So this is the last slide. We talk about, how do you select the process? What is your process strategy? We have 4 types of process. We talked in the beginning of this chapter. We talk about, focused process, which is a lot of varieties and smaller quantities. And also we talk about assembly lines. So, and also product focus. And the next one, it is mass customization. And it's ideal you can handle both large quantity and a large variety. But the reality is, it is the conflict between variety and quantity. So for certain product, you can meet the customer's requirement with customization, but most of the cases you can't. And that's why a lot of companies, they choose their own concentrations. So the concentrations means focus. They select just to focus on one niche of their expertise, because this brings efficiencies, and focus on the depth of product lines instead of the wide variety of the products. So some of the companies focus on customer service. Some of the companies focus on maybe it is product or technology. So they give the example of the textbook. In the textbook, they said, for example, Intel. Intel, this company, they do not produce computers, but they focus all their research and the development and all their expertise on chips manufacturing. They do a lot of chips manufacturing from the foundation and up to now. They are the major kind of like a leader of chips manufacturing worldwide. So, and that's why we say, okay, most of the product, most of the companies, they cannot cover variety and quantity at the same time. They have to select where it is the niche point. They have to focus all their resources on one point. And another part is talking about selecting equipment, because equipment selection is closely related to the process strategy. For example, and in the machining process, so and when you have a lot of options to select, are you going to select CNC brand new machines, or you are going to just buy a cheaper machine? So because machine is going to both of the two machines can help you to produce the product, but which one you like to use? And you say, hey, both is working. Yes, it is true, but we need to consider some other factors to decide whether you are going to select an expensive machine or you are going to select a less expensive. So, and how about what is the machine cost? CNC machine and a regular engine machine, and what is the big difference? Is it 10 times the difference or just 3 times the difference? How about the cash flow? Does your company at this moment and have enough like capital available to invest? Or do you see any kind of like a marketing or potential in the future? And also, what is the customer's requirement about a quality level? So, and how about capacity level and flexibility? And these are all the factors is going to impact your decision what equipment you will choose for the certain process. So process strategy is not a single kind of like decision-making point, and actually it's going to impact the manager's decision in many options, in many aspects. So the rest of the chapters, they talk about process analysis and design. This part are mainly focused on service industry. So when we design a process, when we analyze a process, we have to ask a lot of questions. Some of the questions, like for example, list over here is the process designed to achieve a competitive advantage, or is it try to quickly occupy the market? by quick response to customers' requirement, or is this process is try to reduce the cost? And you have to answer these questions to put your process in a certain niche and unique compared with your other competitors. The second question you want to ask is, does the process, and if you want to implement a new process, eliminate the steps that do not add values? That means, will you increase the efficiency of the process of the company? And then other questions you want to ask is, does the process maximize the customer's value? Will the customer be attracted by the new kind of like process, the result, the efficiency? And will this process help you win the orders from the market and to be competitive with other players? So, in the process chart, and when you design a process, when you analyze the process, normally we like to use certain tools. The tools that we implemented over here is like a flow chart and time function mapping. Flow chart is very simple. It just shows the movement of the materials, and the time function chart is going to not only show the material flows, but also give you the idea how about the time. Each step, how much time is going to take to finish the steps. So like, for example, this is the kind of like a manufacturing flow chart, flow diagram, and to make the cemented carbide and coatings for insert, for cutting tools, started from the raw material. The raw material, it is powder material, and then put in the mixing process, and then you add the additives to make the powders stick together, and then put it into the press. And the next one, after you get the shape you want to make, because after the press, after this step, and it is still kind of like a green product. In order to make the real solid product, you have to put it in the oven. And this is the vacuum and the sintering process. And when after the sintering process, you want to make the geometry or surface requirement. Now you can do the grinding process and then add the coating. That's the final testing process. This is the flow chart. And with kind of like a symbols and the equipment ideas. So, and that's the example of the flow chart. Here is the time function mapping. So, and started from the ordering the product, then the next process is the sales is going to process the order. And then they put it in the bin or somewhere and wait for so long. So 12 and 13 days. So processing is going to take 12 days and the waiting is 13 days. And the next process is print. That's the real operation. So after the first step, printing, and then wait 4 days. The next one, it is the second go to the moving to another transportation process, and then go to another wait process. So totally, after waiting again, go to the extrusion process, then wait, and finally the customer receives the order after 52 days. If you look at over here, wait, so 13 days, and wait 4 days, wait 10 days, wait 9 days. The real waiting time is much, much more longer than the operating time. So from this chart, we clearly can, have a quick glance. You understand, oh, so much waiting time, and it's not a value added time. So, and the time function map help us to try to reduce the waiting time. Now, after the process improvement, you see total process is just 5 days. They reduce the order, and the order processing is just 1 day. And then no kind of like another wait, just go directly to execution process, wait 1 day, and then move it out. So it's a big difference between and after, before and after the process improvement. And this time function chart gives you a clear picture about that. This is the third chart we talk about over here. We call it a process chart. And in process chart, they give you, so even included the moving distance in this chart. So distance in feet. And here is the hamburger assembly process. And I think America is really, really, creative. They even do the fast food companies and promote it to worldwide. So everywhere, probably in the world, around the world, you can find out McDonald's, maybe not Burger King, but I think McDonald's is the most popular fast food restaurant. So they can assemble the hamburger similar to, by using the assembly process, like making a car, making a tractor. So in this chart, even moving distance is included, and processing time is included, and the chart symbol, this is the key part, I think. So the circle representing that's the real operation, and arrow, it is just the transportation, and square representing is inspection. Then this one is a delay. Triangle is storage. So in this case, and if we want to use this chart to help us to improve efficiency, obviously we want to increase the operation time and decreasing transportation, decreasing storage delay. So, and when we look at this chart, you see, okay, the total assembly time is 3.15 minutes. And the real assembly process is 2.5 over here. And another one, it is the 0.2. Here it is assembly, the order, and then 85.7%. Actually, the efficiency is not so bad. So that means your operation time is still the majority part of this assembling process. But there's still room to reduce waiting, reduce storage, reduce transportation. And this is the chart include the distance, time, and operation symbols in the process. And so here's the value strip mapping, the fourth chart. Value strip mapping, they want to look at what is the value added functions or steps in the entire process. And but in this process, not just focus on inside the house of the operation, but also include the suppliers and the supply chains and other kind of like so, and they include the suppliers over here, and include customers in this mapping process. The value strip mapping not just focused in-house, but also include the connections with outside the world, with your working partners. And expanded from the customer back to the suppliers. So they have to begin with the samples from the customer. So what is the forecast of the customer demand? From the customer demand, they are going to decide what is their supplier's shipping schedule. So weekly orders is 2,500 units. And then what is the shipping strategy? So shipping is weekly base. And enter the kind of like shipping includes the truck and the delivery. This is the input over here. This is the output over there. So after that, they add the process steps. So include the machines, component working, assembly, test, and packaging. This is the packaging process. And also they include what is the communication method between the supervisors or the kind of like managers. So daily communication included in this chart. So they have to make sure sending the kind of like a working order to every step to the machines, how many units will be produced. So assembly, so they will to communicate with the individual stations. And in this chart, you also see I. This I means inventory. So inventory levels included over here. And also the processing time, and 45 seconds, 40 seconds, and 15, 20, and 20. These are the producing time or production time at each station. And on the top, you see 5 days, 3 days. So this is the delay. It's kind of like waiting time or sitting with the inventory. So that in this chart we see, all the value added time is 140 seconds. However, the non-value added time, inventory time, and work in process is 26 days, which is the non-value added process. So, and this gives us an idea. We have the big room to improve the current process and to reduce the non-value added and operations. Maybe they have to change their inventory schedule and then reduce the inventory. And inventory means you have to use a lot of cash flow in the process. And then value stream mapping. The next one, it is a service blueprint. And here, service blueprinting mainly focuses on the customer and provider interactions. There are 3 levels of interactions in the service process, and each of the level has their own kind of like main players, who is the dominant person, and also give us the idea where it is a potential risk point or failure point in the process. Here is the service blueprint, and I'm not sure whether you have the experience to work with someone, and okay, you want to go to a car maintenance shop, okay? So you want to balance your tires, the front tires and the rear tires. So when you go to Toyota's service or Walmart's auto service, first you go over here, and customer arrives. That's the first level. When you arrive over here, normally there will be some kind of like a ding dong from the door. So will cause the receptionist attention, right? So they will say, how can I help you? And then at this moment, and I think the receptionist or whoever is in charge of the front desk, he or she must have a little bit kind of like knowledge about tires, about their service level. So they will ask, what do you want? And then the customer will say, oh, I want to, to do some kind of like a tire service. First of all, they will find out what is your tire, when was the last kind of like a service, and how many years from the last service to now. Because one time I went to Walmart's tire services and they said, oh, I will not do your service because your tire is, it is already worn out. I said, what? Is it just 2 years? So, or just a certain type. They give you some kind of education. They said the trap, okay, the kind of like we don't do this service anymore because it looks like your tire is already, it's too old. This will give you some kind of like education. And then if they say, oh, it's okay, and we can do the service over here, they will ask, then it will go to the next level. The next level, they will say, is this a standard service or it is a non-standard service? So, and obtain the service request. And the next one, if this is a standard service, yes, we can do over here. So probably you have to wait 30 minutes after it's done. So, and then we'll jump to the level 3. And if it's not the standard service, now it's going to go to the next level. And they will say, can the service be done? And does the customer approve it? Because they said, okay, I can do your service, but it's going to, do some extra charge. Are you okay with that? If it's not okay, and then, they will go back. So give you some other ideas, recommendations, or you may go to other shop to check if they can do it or not. So, and the next, if it's okay, if the customer is okay with the extra charge, probably they will go to the backside, the level 3, and perform the real service. So, and after finish the service, they will tell the customer, oh, it is ready, and pretty much you just pay, and then you can and finish all the kind of like a service and a departure from the this shop. So this service blueprint gave you 3 levels, and in the very first level, education to the customer. And at this moment, a customer probably is the main kind of like a dominant part, and to tell what, okay, and what do I want, and then level 2, that's the main interaction between the customer and the service provider. You want to find out detailed specifications, what is the customer's need. And in the level 3, in the backside, there's less interaction between the customer and the service provider, mainly just perform the function. Here, in this kind of like a chart, they also provide you some kind of like a time. So 10 minutes and 10 seconds. So here is 3 minutes. So time is included over here in the service blueprint. And also they have some kind of like what do we call? Rainbows, or kind of like a decision-making symbols. Decision-making symbols, and when you have, is this a standard request? Yes or no? If it's a yes, just go to a branch to do the service. If it's a no, you have to ask other questions. So, and then this decision-making point is very critical, and will help you to diagnose and find out what is the customer's real need and a real want, okay? And this service blueprint is somehow a little bit similar compared with compared with other chart, you know, and flow chart also give you the information flow over here, and also include the decision making, something like a flow chart can do as well. But that main function of the service blueprint, it is to include interaction between customer and service provider, and also find you specifically what is the customer requirement. And so the chart we discuss over here, service special considerations for service process design. You know, some of the interactions with customer is necessary. So, and this often will impact the performance adversely. The better these interactions are accommodated in the process design, the more efficient and the more effective the process will be. So, and basically it's trying to encourage you to find out, diagnose what is the customer expectation, and find the right combination of cost and customer interaction, and from this chart. So, and some of the service improve some of the techniques used to improve service productivity. Our textbook lists some of the strategies over here, and they include separations, self-service, even postpone, and focus. And you can read by yourself, okay? And for example, separation actually means structuring service, and the customer will go to a specific desk, a person who help you. If you go to the bank, so if you say, because go to the bank, you may just want to cash out some money. So that's very simple, right? So go to the teller, go to the teller, you can deposit or cash out money. But you said, I want to go to the bank and find out a loan. And then the teller will not help you to do that. You have to talk with a specific loan officer over there. So that's the separation or structural service. And some others, and self-service. Right now, I think every kind of like supermarket, Hy-Vee and Fairway and Walmart, you can find out a checkout service by yourself. So, and some other technologies or techniques to help you to do the self-service include even automations and modules and trainings. Obviously, training and is necessary for any of the industries, no matter it's service industry or manufacturing industry. They all need training and to help improve the entire overall productivity. So the next session, so we want to give you some ideas about the technologies used at this moment to improve production technology. Obviously, machine technologies and CNC machines, new machines, EDM machines, and some of the, I think, revolutionary kind of like ideas is CNC machines compared with the old manual machines increase quality and increase repeatability. A lot of advantage over there. Now the high kind of like a term, popular term is 3D printing machines, which is additive manufacturing and machines. They can help you to not only prototype new designs, but actually can be used for real production. And so automatic identification system. So we call it AIS, or radio frequency identification system. And what we can see is, the similar technology, data processing, and can help to improve the data acquisition, and so increase the speed. So when you go to the market, you just punch in the code, 4 digits code, and then the automatic system can help you to identify what is this grocery produce and what is the charge for this produce. Okay, they also use a barcode you can scan to find out the product information. These are all based upon sensors, based upon like automatic identification, tracking, and the frequency, radio frequency identification system. So process control basically is to use the sensors to collect the data. And this is extremely important for chemical industry, food industry, and to track pressure, temperature, and track the volume of or the velocity of the food or chocolate, milk kind of like a process. They use sensors to collect the data, and then computer can collect the information right away, and to kind of visualize the data in the computer system, and then whoever is in charge and observing the data, they can get the quick visualization of the process. Another visual system, so visual inspection, and cameras, vision identification, because camera will never, computerized camera can never feel bored, or they can always be accurate, not just like a human being. After seeing 1 hour, they will, not like to do the boring tasks. Obviously, robots has been used more and more, and in today's manufacturing industry. So this is the robot. I think it's very similar to the ABB robot we have in the department. And they can perform tasks requiring significant kind of like strength or endurance, and never feel tired unless it's programmed wrong. Okay, so can maintain good consistency and accuracy. Here is the storage and the retrieval system. I went to kind of like a distribution center similar to Hy-Vee. So this summer I went to their distribution center. This is kind of like a big grocery chain in Texas. I see a lot of like kind of like conveyors and a belt, and even like cars, and all the operators, they wear kind of like a pad on their wrist, and this pad will help them to identify, to give them what they need to grab, what they need to package, put it in their cart. And they use robots as well to locate where it is kind of like package they want to find out to put in the conveyors, reduce errors and labors. It's very useful in the inventory and kind of like a distribution center. So I'm thinking maybe we should organize a field trip in Target, like a distribution center. I believe they have the similar system. Myself, I haven't been there, but this is the online class or face-to-face class. I never know how many students will be there. If I want to organize the field trip to visit a Target distribution center, how many of us will be interested in? At least I want to, to have like 8 or 10 people to visit them, right? So if we only have 3 or 4, they will say, how many students do you have in the class? I said 37. They said, what? Why you only have like 3 or 4 people to come? I feel not good. So I think it's very, very good. I myself, I went to the distribution center. I was very impressed. So AGVs, yes, I did see AGVs in the distribution center. So another one is a flexible manufacturing system and a computer integrated manufacturing system. So everything, it is integrated together from the design to production to like storage to inspection. Everything you have to be to use the integrated computer network. So, and I will stop over here. So today you just submit the in class 9.2. Okay, so next class on Thursday we probably will give you time to do in class 10, practice 10.